This problem is the homework problem from implicit differentiation, and this problem is particularly challenging because first of all, there's quite a bit of algebra involved in the differentiation, but also when we try to solve for the tangent lines, we're going to have to recognize that we have a system of equations and figure out a way to set up a system for this. So this is strophoid. It has a domain of -4 to 4, so it starts at -4. There is a vertical asymptote at +4. Okay? So what we want to do then is we want to differentiate this implicitly. So we end up with 3x squared plus 8x plus, now this portion here involves a product rule. So we have to make sure that we differentiate as a product. So we differentiate the x, leave the y squared, plus we differentiate the y squared into 2y, and since we're differentiating a y at this point, we use the chain rule to get y prime. So here we did not use the y prime because we did not differentiate the y in this case. So the next part here, so we're going to end up differentiating 4y squared, so we're going to differentiate the squared first, and again, now that we differentiated y, we have to apply the chain rule, and that's equal to 0. So we need to solve for the y prime, so I'm going to group my y primes. So I'm going to end up with y prime. Here I'm going to end up with 2xy. This term is going to be minus 8y. Okay. All the other terms are going to go to the other side of the equation, so I'm going to identify those terms. So I have terms here, here, and here. So those terms all go to the other side of the equation. So it becomes -3x squared minus 8x minus y squared. Okay, so there's my derivative. Right here, y prime, I solve for y prime, and I end up with -3x squared minus 8x minus y squared, all divided by 2xy minus 8y. So I'm going to factor the common factor of 2y, and I end up with x minus 4. Okay, so this is going to be where it's equal to 0. Okay, I'm going to get rid of the denominator here to make this a little bit easier to work with. Okay, so I'm only going to solve this equation. But before I get rid of the denominator, I have to make sure I state some restrictions. So y is not equal to 0, and x is not equal to 4. And we can see at y equals 0, we have vertical tangent line here, or sorry, this is x equals 0, y equals 0. We can evaluate that. At x equals +4, okay, we end up with this vertical tangent line, so we can't affect that. And at y equals 0, x equals 0, again, we have a vertical tangent line. So we're looking for these tangent lines in these spots right here and here. Okay, so that means we need to set the derivative equal to 0. So when I do this, I'm going to rewrite the equation. 3x squared, -3x squared, minus 8x minus y squared is equal to 0. And the problem I have here then is, to solve this equation, I have two variables, so I need a system of equations if I'm going to solve this. So I have one equation here. I need to come up with another equation to be able to have a system of equations. In the other equation, the only place I can find another relationship is up here, the original equation. So I'm going to do a substitution here. It looks much easier to substitute for y squared than for the x's. So I'm going to take that equation and I'm going to rearrange it for y. So I get y squared, and I'm going to factor the x minus 4, and that's equal to, I'm just going to shift that down a little bit. Okay, that's going to be equal to, and I'm going to move all the other terms to the other side, so I end up with -x cubed minus 4x squared. Okay, solving for y squared, I end up with, I'm going to factor the -x squared out. I end up with x plus 4. Okay, and then divided by x minus 4. So I'm going to replace that y squared then using this system of equations. So I've got my original equation for my derivative. My second equation is based on the original function. That's the relationship between x and y. So I can then substitute and solve for this equation. So the system. So I get negative 3x squared minus 8x minus, and this is going to end up being negative x squared x plus 4 all over x minus 4, and that's equal to 0. Okay, so taking this equation, I'm just going to move it over so I have room to work. I'm just going to move it down here. Okay, I just need to solve this equation for x, so I'm going to multiply both sides by the denominator, x minus 4. Okay, again, I've got my restriction of x not equal to 4 already, so I'm going to end up with 3x cubed minus x squared plus 12, plus 12x squared plus 32x, and then I'm going to end up with plus x cubed plus 4x squared. Okay, I think I got my signs right. Make it equal to 0, collect my like terms. So I end up with, looks like I have positive 16x squared minus 8x squared, so that looks like positive 8x squared. And if I've collected my terms correctly, I have plus 32x, and that's equal to 0. I'm going to factor this. So I end up with x squared minus 4x minus 16, and that's equal to 0. So my solutions are going to be x equals 0. Okay, at x equals 0, y equals 0. Okay, and we have this restriction here, y can't be equal to 0. So that is not going to be the horizontal tangent. I'm going to then solve the other part of this using quadratic formula. So I end up with negative 4 squared minus 4 times a times c. And that's all over 2a. Okay, this simplifies to 4 plus minus square root 80 over 2. Simplifying this, this becomes 2 plus minus, factor the 16 out as 4, so it becomes 2 root 5. Okay, so if I use x is 2 minus 2 root 5, okay, I get it, I think about 2 point something, negative 2 point something, which is in the domain, and it looks like if I take a look at my graph, that looks about the right spot for my horizontal tangents here and here. If I let x equals 2 plus 2 root 5, well, that's greater than outside of our domain, so we know that this is an extraneous solution. Okay. So then at this point I have my x position of my horizontal tangent. I just need to find the y position. And to find the y position, I'm just going to plug it back into this equation. So I get y squared is equal to negative of 2 minus 2 root 5 squared times 2 minus 2 root 5 plus 4. Okay, and that's all over 2 minus 2 root 5 minus 4. Okay, so I need to do some simplification here. This is just a lot of grunt work algebra, but I'm going to end up with 4 minus 8 root 5 plus, that's going to be 20 plus 20. Okay, here I get 6 minus 2 root 5, and in the denominator I'm going to end up with negative 2 minus 2 root 5. Okay, maybe get rid of that negative here. So y squared is equal to, I'm going to multiply or combine like terms here, so I'm going to get rid of the negatives first. So I end up with 24 minus 8 root 5 times 6 minus 2 root 5, and that's all over 2 plus 2 root 5. Okay, expanding this out, 6 times 24 is going to give us 144. Negative 48, so it's going to be minus 96 root 5, and then plus 16 times 5, which is going to be 80. And that's all over 2 plus 2 root 5. I don't think anything simplifies here, so we can just, I think we can just square root everything here. So we get plus minus, we get the y coordinate above and the y coordinate below. So this is going to work out to be 224 minus 96 root 5 all over 2 plus 2 root 5. And we can do a little simplifying here. We get 112 minus 48 root 5 all over 1 plus square root 5. Okay, so there's my y coordinate of that answer. Again, this is very involved and there's a lot of algebra stuff in here. But the key to solving this is really to, first of all, be able to work out the derivative, recognize that we have two variables and we need a system of equations, and to use this original function as the other equation in that system.